Hello, everyone. Today we are going to talk about friction. So you can see in the image here, I have two different types of friction, kinetic friction and static friction. These are the two we really are going to go into today. I'm going to go into a third one briefly, but it's not super important for AP Physics 1, more important for AP Physics C. So I want you guys to know that it exists. We don't need to quantify it. All right. So understanding our lab, we just performed a lab looking at how we can quantify friction. We pulled a block across two different surfaces and we got a graph that looks kind of like this. So pointing out in our graph, you should have had an increase. It might not be this steep, but an increase like this, and it's going to peak and then drop down to an area where with a plateau. The area with the increase is static friction. And then the plateau is going to be our kinetic friction. Now, in our lab, we did not see rolling friction because our object was not rolling. So static friction, this is the force that keeps an object from slipping. So if you think about our lab, this was the force friction that was in place when our object was not moving quite yet. It was that friction that opposed our potential motion. We typically notate this as F and S. So friction a lot of times gets a lowercase f when we're talking about it. We might not do the big F, low subscript F and then S. You might just see lowercase f and S. Kinetic friction is the force on an object when it's sliding. Typically, this is the one we're going to be talking about, and this opposes motion. Now, this you might also see it moving. So sliding or moving here, but this is going to oppose motion. So if I'm moving to the right, my friction would be going to the left. Our last one we did not see in our lab, but it would be rolling friction. Rolling friction is when an object is rolling. It's that friction that causes an object to roll. We're not going to look at this a ton in this class, but we will see it in our rotation unit. And I think a better way to put this is force on an object while moving, mainly on an object while rolling. And since these are all friction force, they're all measured in newtons. Now, the equation for this, we get force friction is less than or equal to the coefficient of friction times force normal. Now, typically, we're just going to write this as FF equals mu Fn. Mu is the Greek letter that coefficient of friction is, which is that U with the front loop on the front and back. Now, this less than or equal to comes into play because of that steep graph and the static friction, that changing, because static friction is only going to match the applied force that's applied to it. So if I have a force of, and I'm going to draw on here real quick. So if I have a force of 10 newtons to the right, and then it says the object's not moving because of friction, we would have a force of 10 newtons to the left because that static friction is going to match whatever the applied force is. However, once we overcome that peak, like we saw in our lab, and we get the object moving, you're going to see that kinetic friction is a lot lower. Now, if you're looking for this equation on our equation sheet, you can find it right here. As I said in the previous videos, our forces equations are kind of all over the place. But we have friction force, normal force, and coefficient of friction, which is sometimes called mu. In this equation. Now, this coefficient of friction is a new idea. This is the ratio between the normal and the friction force. There is no unit to this because it's a ratio, and it strictly depends on the two surfaces that we are looking at. So you can see here, you do not need to write down this chart, but if you look at this chart, you can see that we've got rubber on dry concrete, so like a wheel on concrete, rubber on wet concrete, wood on wood, waxed wood on wet snow, like a sled or a skiing, metal on wood, steel on steel. There's a lot of different options here. One thing I want to point out to you, the coefficient of static friction is always going to be greater than the coefficient of kinetic friction. That's because of that peak that happened in our graph right before it dropped. So that also tells me that my static friction is always going to be greater than my kinetic friction. I only have one example, so we're going to jump into this. Our one example says determine the coefficient of friction or the drag factor, that's another interchangeable term, for the surface. We want to show all work in units. Then we're going to determine what surface they're on. So we're given the information that the mass of the vehicle is 1,785 kilograms, and the force friction of the vehicle is 14,519 newtons. So let's imagine the situation we have here is like a car is slamming on their brakes and sliding across a surface. So if I were to draw a force diagram for this setup, I would get force normal up, force gravity down, and force friction would be the opposite direction of motion. If it doesn't tell me, I always make the direction of motion to my right, so my friction would be to the left. The very first thing I want to do, I know my force friction, so I need to look at my, I need to solve for that normal force. And here, since we have everything balanced, normal force is going to be equal to our gravitational force. So I want to start by solving, if I can solve for that gravitational force, I can have my normal force. Now, this is not always the case. Once we have trig start to get into play, or we have acceleration in the y direction, force normal might not be equal to force gravity. But for this circumstance, we are still saying they are equal. So we say force gravity is equal to m times g. And I'm going to plug in that 1,785 times 9.8, which gives me force gravity, or force normal, of 17,493 newtons. Now I'm going to look at my force friction equation, the one we're introducing for this lesson. Force friction is equal to mu Fn, or force friction is equal to our coefficient of friction times Fn. And I'm going to plug in what I know. We know our force friction is 14,519 newtons. We're solving for that coefficient of friction times 17,493. I'm going to divide that 17,493 to the other side, which gives me a coefficient of friction of 0.83 newtons. One thing you're going to notice a lot, this ratio is typically lower than 1 because, again, it's a ratio. Now, looking at this, I'm now going to compare it to the chart of the different types of surfaces I have. Now, looking at this, I have two that could be factors. I could have my cement here. I could have cement, or I could have asphalt. Now, gravel's a close contender, but you see how we're just outside of that range. So since we're just outside of that range, it's not going to be gravel. It's going to be cement or asphalt. Now, I know I went through this example quickly, but this is pretty much the simplest these friction equations will get. These problems are going to get a lot more complicated. So I don't want you to think this is where we're leaving off, but we're going to just introduce the equation, and then we're going to get more complicated in the next couple units as we introduce Newton's laws, we introduce acceleration, we introduce balanced forces. So I want you to keep this straightforward, the simple example in mind as we get to more complicated stuff.